in single linked list, you can only traverse in one direction. You have a list like this, this is null and this is your head pointer. So, you are pointing only towards the front part this way. You have element 10, 20, 30 and 40, right. In single linked list, we say we have the head always points to the first node and the last node always has a null pointer, right. So, assume you are having 1000 nodes in a list, 1000 nodes in a list. Now, we are doing one operation, deleting an element. You want to delete element at 990th location. In this location, you want to delete an element. So, in that huge list, right, of 1000 nodes, to delete an element at some particular position or to insert a new element at some particular position, we have to traverse the list. We have to traverse the entire list. From the beginning, I have to move forward. I have to go 990 times. I have to traverse every element, because the logic will keep checking always. Is the temporary variable temp next not equal to null? This way it will keep checking in while condition. Until this is not null, it will keep traversing, it will keep visiting every node of the list, right. So, when I want to delete a node at this location, 990th location, I am unnecessarily traversing everything. Okay. So, to reduce the cost of those operations, cost in the sense the time taken for traversing the entire list, we have to we use the concept of double linked list. Implementation is almost same, or the concept remains same, a few changes in the node structure, rest all is same. Okay. It will be very easy for you when you understand the operations what we perform on the double linked list, right. So, single linked list, okay, it is dynamic in nature, we can insert an element at any location, it is very easy. To improve it more, to improve it much better, we are going for double linked list. I cannot say this is a drawback, but it can be considered as a drawback, that to traverse, to insert an element at the end of the list or last second element, I am traversing the entire list. If the list is small, okay, but if the list size is very large, okay, if the list size is very large, something like this 1000 nodes, then in that case unnecessarily we are traversing 990 times. Okay. So, that is why there is another alternate for single linked list, that is double linked list. What is this double linked list? Right. Same as single linked list. In single linked list, the node structure contains only two parts. This is data part and this is the next part, the pointer which points to the next element. Whereas in double linked list, our node structure has three parts. It has three parts. This is the center is your data part, this is your previous pointer and this is your next pointer. Okay. In double linked list, you can, in single linked list we observe that we are only traversing in one direction alone, whereas in double linked list you can traverse in both the directions. Either you can go front, you can come back. Okay. You can, this is your head pointer, right, this is your head pointer, and here you will have a tail pointer. Here you will have a tail pointer. So, you can either go this direction, you can come this direction, you can go front, come back, any way you can do the operations. Okay. That is double linked list. Now, why I need three sections here? One is obviously for data which I have to store. Next is a pointer. So, I have a one memory location as next. This is pointing to the next node. Okay. Then we have another location here, another pointer here which is pointing to the previous node, So, in the structure format of double linked list, it has three variables. One is to store the data, other two to store the pointers or addresses of the next node and previous node. Both I have to maintain, only then I can traverse in front or back directions. Okay. So, this is how double linked list works. If you see, it looks something like this. If I draw a small list, Suppose this I have 4 elements like this 10, 20, 30 and 40. Okay, we always know where will head point, head is point always into the first node, head will be pointing to the first node, and the last node's next pointer will be null. This also we know, right? Now here we have 2 pointers, one will point to this and this will also point to this previous location. It means in a node I am storing 2 addresses, address of my previous node, address of my next node. I am storing 2 addresses. That way we are trying to link it, so that anywhere you want to come back, you can always take the reverse direction, right? So this way it is linked. This is normally null. You see the first node's left pointer, this box, okay, the first node's left pointer also will be null because there is no previous element. Since there is no previous element, the first node's left pointer, the left pointer will be null. So this is how your double linked list looks like, right? Now we will try to explore how we perform the operations on a double linked list. What are those operations? In insertion we have 3 operations. In deletion we have 3 operations, right? What is that? Inserting at the beginning, at the end and at given location. Deleting at the beginning, at the end and at given location. That we will try to explore how we perform the operations on a double linked list. Okay, it is very important, you all should know to write that code snippets, that small blocks of code to perform the operations. It is very popularly asked interview questions. In face-to-face technical interview questions, they ask you, they give a list, they ask you to write how do you perform deleting an element at any given location in a double linked list. So that small piece of logic you have to write, or logically you should be able to explain them how it happens. Okay, and if you if you observe in single linked list, if I just go back and we discuss this, deleting at any position in a single linked list. Just I am going back to single linked list. In single linked list, when you want to delete any element at any location like this, okay, at the position, at any given position I want to delete. If you remember, I told we have to use 2 pointers P and Q, right? We have to use 2 pointers P and Q. Initially P will be here, and then you will check if this is null. If this is not null, you will make this as your P and this will be your Q. Again check if this is null. If it is not null, make this as your P, let this be your Q. Again you come forward, make this as your P and let this be your Q. That way we were traversing yesterday, right? Maybe in this case we have to bring our Q here and bring our P here. So sometimes they ask these kind of questions in interview, that how many pointers are required, okay, how many extra pointers are required to perform this operation. So in this case, deleting at any position, I need 2 pointers P and Q. Other cases you see, deleting at the end also I need 3 pointers. Okay, that way they may ask you, see, in deleting at the beginning I don't need any extra pointer, only 1 pointer is sufficient, or 1 temporary variable is sufficient. Okay, so these are very popularly asked questions from linked list. Same way in this double linked list, when you are performing an operation, it's quite common, but because it looks very complex structure, you might need some pointers. So to perform insertion operation at the beginning, how many pointers are required? At the end, how many pointers are required? These kind of questions also can appear from single linked list or double linked list, right? So it is very important, you should know the logic how we are trying to perform these 6 operation. There are so many placement level questions on linked list which are majorly based on these 6 operations for single linked list or double linked list, whatever it is. Okay, so you should know how to write code for these things. So let us dwell into the double linked list concepts. So that's what we discussed. Double linked list is a linked list which with a node contains a pointer to the previous as well as to the next node in the sequence. It is also called as two-way linked list. Double linked list also called as two-way linked list. It has 3 parts. One is the data part, next is a pointer to the next node, another one is a pointer to the previous node. Like this, we will have 3 parts in a node. So this is for data, This is for previous, this is for next. So, store address of previous, store address of next. This is the structure of double linked list. Okay. One advantage is that we can navigate on both directions. You can go forward or also you can come backward. This is allowed. In single linked list, I can go only forward, I cannot come back. If someone asks you, print the elements in the single linked list in reverse direction, it is not possible. See, you have a single linked list with elements like this. Okay, 4, 7, 1, 15. If someone asks you, print this in reverse order, how do you print? You have one pointer head here. You have one pointer head. You can go next only. You can go next only. Okay. From there again, you cannot come back. You cannot come back. It is difficult to print the linked list, single linked list in reverse order. But in double linked list, if you want, you can do it because we have two paths, one to front, other to back, like this. Okay. So, you have both the directions. You can either go front or do it back. So, those benefits we have in the double linked list. But there is one drawback also in double linked list. What is the drawback? Unnecessarily I am creating extra pointer. You see, in single linked list, what was the size? This is data part, this is the pointer part. So, this requires 4 bytes, this requires 4 bytes. Total with 8 bytes we completed the memory allocation, but here I need 4, 4, 4, total 12 bytes. So, unnecessarily we are storing this extra 4 bytes of space. That is what they say here. See, each node requires an extra pointer requiring more space. Okay. And inserting and deleting a node takes longer time. Why it takes long time? Because there are multiple links between the nodes. Okay. Between the nodes there are 2 links now. I have to modify both the links. So, it takes time. So, there are some benefits and some drawbacks as well for double linked list compared to single linked list. That is why when you see linked list concept comparing with arrays like we have discussed, right. If you see this is much better compared to arrays. Again, array has its own benefit, linked list has its own benefit. In this single linked list has some drawbacks and benefits, double linked list has some drawbacks and benefits. Okay. So, we will try to now see how do we perform the operations on double linked list. So, the most important one is declaring a structure, right. We are using the concept of structure to create a node. Why? Because I want to reserve a memory in your RAM with 3 boxes like this. To do this, it is a combination of multiple different data types, because this is a normal variable, this is a pointer variable, and this is also a pointer variable, because we are storing addresses. So, I have to definitely use structure. What is the structure for single linked list? If you remember, it is just a struct node. In this I have one element int data, and the next element will be struct node star next. Like this I will have only 2 variables here. One is data part, other is to store the address. Whereas in double linked list you need to store 2 addresses, right. That is why you have struct node int data, struct node star next, struct node star previous. Okay. So, we are having 2 pointers here, one to store the previous node's address, the other one to store the front node's address. Okay. This way we can create a structure for double linked list. It has 3 elements, data, one is the next pointer, other is the previous pointer. Okay. Both are of type struct node. That is why in linked list we say we use self-referential structure. Why is it so? I will repeat this once again. Why are we having self-referential structures? Because when you write pointer int star ptr, or when you write char star ptr, it indicates that this ptr is a pointer variable. It will store address of this type of data variable. This ptr is holding some address. This address belongs to element of character data type. Okay. That is why here in this structure linked list, what I am storing here, which address I am storing here? I am storing address of another element. What is that element type? That element type is structure. The element type is this node type. That is why we are referring the same structure in the structure definition of linked list. So, with this we understood now. Now, let us see the operations, those 6 operations. First we will try to see, okay, first we will try to see the double linked list operation. We will see the implementation part of single linked list deletion, but since first hour it is easy for us to learn some new concept, I have jumped into explaining you double linked list. We will definitely see the implementation of deletion of single linked list. Okay, we will see that. But as a fresh, I thought you will understand this better, so that we can go there and you can perform the, we will see the coding part of single linked list deletion operation implementation. If required, we can see the single linked list insertion operation again and then come to deletion part. No worries. Okay. So, this is how we declare it. Now, what are the operations here in double linked list? We have 3 operations. Insertion has 3 operations: inserting at the beginning, inserting at the end, inserting at any given position. Let us see each one of them. How do we insert an element at the beginning? So, now first step, if you remember, in single linked list, you already had a list like this. Okay, you have a list like this. This is your head pointer. What I have to do? I have to first create a structure like this. For this, I have to write 2-3 statements which will create a RAM and add some value and put null here. Then what I have to do? This is my new node. New nodes next should point to head, and we should make this as head. This was our logic to insert a new element at the beginning in single linked list. Same way in double linked list, when you have a double linked list with you like this, okay, null is here and we are having directions in both the ways, and this is also null. This is our head pointer. What is the first step here in double linked list insertion? At the beginning, I have to create a node structure with 3 blocks here. For that, I can write allocate memory using malloc statement and assign value 10 here and put both of them null. This is fixed thing which we have to do. Now, this name is new node. Its name is new node. So, new node's next pointer should point to head. New node's next pointer should point to head. Head's previous pointer should point to new node. Head's previous pointer should point to new node, because there are 2 pointers now, next and previous. So, new node next should be pointing to head. Okay, new nodes next should be pointing to head. Then this link is created now. This link is created. So, head's previous should point to new node, right? So, head's previous should point to new node. When you do this, this chain is established. When you do this here, this link is established between both the nodes. Now, where is your head? Head is here. So, one more command we have to write. We have to make this as our head, because head always point to the beginning of the list. For that, what I have to do? Just write head equal to new node. Head equal to new node. So, this becomes our head. That's it. This 3 is the logic to insert an element at the beginning of the double linked list. Okay, let us see once again, try to understand how we try to insert an element at the beginning of the list. See, first thing, you have to create this new node structure, mark them both of them as null. The second thing, new node's next pointer. New node's next pointer you should point to head. This is first thing. Second thing, head's previous should point to new node. Head's previous should point to new node. Then the last thing, we have to make this as our head. We have to make this as our head. Okay, like this you can perform insertion operation in a double linked list at the beginning. Okay, I will repeat once again what we are trying to do. You have to first create an empty structure like this. Then you have to mark them both of them null and put some value 10 here. So, you can create this using 3 or 4 statements. After that, what I have to do? This is my new node now. This is my new node. New nodes, I want to insert the element at the beginning. It means before head. This is my head. Before head, I want to insert. For that reason, what I have to do? This new nodes next. This is next part. No, this is previous part. Okay, this new nodes next should point to head. Step number 1. Step number 2, heads previous. This is heads previous. This is heads next. So, heads previous should point to new node in reverse direction. That is the second step. Third step, make the new node as head. make the new node as the head. That's it. With these three changes, we can insert an element at the beginning of the double linked list. Okay. Let us try to implement see the logic. Okay. It is same as how you inserted the element in the beginning of the single linked list. Any doubts here till now? Are you understanding what we are discussing? Please let me know if you have any queries. Double linked list, why are we moving, how are we performing operation? Students, please respond. Okay. Right. So, double linked list. Why we need to go for double linked list is that in single linked list, traversing is a problem. I cannot go, I cannot come back. I cannot come backward direction. I can only go in one direction. To overcome that, they have come up with the concept of double linked list, where I can go in different direction or I can come back in back direction. I can come in back direction as well. That is one major thing here. The second thing is, for that reason we have to maintain two pointers. One is the previous pointer, other is the next pointer. We should have two pointers, one to store the previous node's address, the other one to store the next node's address, previous node and next node's address. Okay. Like this we are storing two elements, two addresses. Okay. So, we have seen the structure representation or declaration of a double linked list. It has three elements: int data, previous and next. Okay. These three will help us to create this structure. It will help us in creating this structure. Okay. Node. I can have this box. I can get my memory reserved by creating a variable for this structure. I can get my memory reserved like this. Next, the first operation is inserting an element at the beginning of the double linked list. So, you want to insert an element. For that, you have to create a new node first. So, we will write some commands like this. You see, new node equal to struct node star malloc struct node type. This will reserve memory in your RAM like this. This will reserve memory in your RAM like this. Next, new node data is data. I am passing here, I am giving the value 10, assume we are giving the value 10. So, this will be assigned to 10. Next, new node next equal to null. New node's next is this, right? This is previous. This is the data part. This I am putting null, and new node's previous equal to null. This also I am putting as null. So, with these four statements, okay, with these four statements here, we will be creating a node structure and inserting some value into that node. These four statements will help us in creating this. This is fine. Now, to this function insert at begin, I am giving head as I am giving the address of the head. Okay. Assume if head is null, it means there is no element in the linked list. This is the first element if you assume. In that case, what I have to do? I have to make this as my head, right? If there is no element in the list, I have to make this as my head. Okay. But if I make this as head, my job is done, because there is no element in the list. This is the first element in the double linked list. For that, if I can just make, see, head equal to new node. If I do that, this becomes my head, and that is the only element in the double linked list. And since this is the only element, we have to make sure that this is null and this is null. That again I am rechecking it. Need not do, but it is already there in that place. Okay. So, that is the logic of this if condition. If the head which is given as input to the function is null, then it means this is the only element in the list. Okay. For that, you have to make this as the head and make sure these both pointers are null. If not, assume there is, if not, there exists some big list like this. Okay. There are some elements already in the list, and this is your head pointer. Here this will be null and this will be pointing to front. Here we have element 20, 30 and so on. Now, what I have to do? I want to insert an element at the beginning. When I want to insert an element at the beginning, this box I want to place it here like this. Now, 10 is there, null is there, null is there here. This is my new node. This is my new node. this is my head. Okay, in head the previous pointer is null, in the head the previous pointer is null. So when I want to link these two, this new node's next pointer, this new node's next pointer, it should point to this new node's next pointer, it should point to the head, so that this chain is created. See, new node's next is pointing to head, this chain is created. Next, head's previous means this box, head's previous should point to new node like this in reverse. See, head's previous equal to new node. So we got this chain created. Now this chain is there means this is not null anymore now, and this is not null anymore. This is null. That is okay, because for new nodes left we don't have any other node. So this is null, okay. Now third step is your head should be always pointing to the beginning of the list. So we have to make this as our head, and this should be removed. For that we are writing head equal to new node. So new node we are making as head. That's it. We are able to insert an element at the beginning of the list. Okay. So this is the code to insert an element at the beginning of the list, right. So what I am doing, again I will repeat this code. I am calling a function, I am giving the head. Why am I always giving head as the input to the function? Because that is the only pointer we have in linked list, whether it is single or double, that is the only pointer we have in the linked list. So I have head pointer, and we have the data. Why? Because I have to insert a new node, that information I have to give to the function. So I am creating a temporary pointer. Temporary is not required, this is maybe a wrong statement, this is not at all required here, this line. So you write this function. This 4 fixed steps will be there in all the operations of double linked list creation, whether you are inserting at the beginning, at the end, at any location. Okay. These 4 points are common. Why? This malloc statement will allocate memory. How much memory it will allocate? It will allocate this much memory. How much means this much. What is that struct node? Struct node means how many elements are there here? 3. So this requires 4 bytes. Assuming it is 4 bytes for integer, it requires total 12 bytes, right. So this much of memory will be allocated using this malloc statement, and its name is new node. So with this, a memory block like this will be created in your RAM wherever there is a free space, okay, and its address is stored in a variable new node. So that is why it is pointing to new node. Now new node's data, this is my data part, this is my next part, this is my previous part. So new node's data, I am including the data which I am giving as the input. So let this be 10, so 10 comes here, because I am passing 10 as the parameter to the function, 10 comes here. Now new node's next I am putting null, it means I am putting this as null. New node's previous I am putting null, I am putting this as my null. This way these 4 statements can create a node like this. Now you can think whether you want to insert this at the beginning, you write that logic accordingly, right. So for that, before that we have one check. What is the check here? That if the head is null, if the input which is given to us is null, it indicates that list does not exist at all. In that case, this is the only element I have in the list. So just to make this as head, that's it, game is over. Already this is null, this is null. Okay. If it indicates that there are some elements already in the list, okay, then you have on your head node here, this is your head node, this will be initially null, this will be 20, and this will be pointing to something like this. Now what you have to do, this new node's next, this box should point to head, and head's previous should point to new node. See, new node's next should point to head, head's previous should point to new node, and the last one we have to make this as our head. Why? Because head should always point to the first element of the linked list. So just to shift your head from here to, you make this as your head. Okay. So this is the logic of inserting an element at the beginning of a double linked list. Additional pointer previous is added compared to the single linked list operation, right. Any queries till now here? Is it clear? Understood the operation? Students, please respond. Okay, right. Let's move to the next operation, that is inserting an element at the end of a double linked list. Okay, that is why we will always revise how to insert an element at the beginning. That we will try to see first for a single linked list. Before we go for double linked list, how do you insert an element at the end of a single linked list? That logic let us revise. So, if I have a single linked list like this, I know definitely this is my head pointer and this will be null, and this is linked in this way. I have elements 10, 20, 30 and 40 here. Now, how do we insert an element? Okay, how do we insert an element at the end of a single linked list? For that, what we have to do? First thing, we have to create a temporary variable without impacting head. Let that temporary be equal to head. So, it is temporary variable will be pointing to head. Then I have to traverse each node until I find a node with null at the next part. Okay, keep traversing the list until you reach the end of the list. How do we identify end of the list? There is a principle that the last node of a linked list will be null, like this. Its next value, right? So, temps next, this will be null for the last case. Okay, till that you have to go. So, once you reach here that it is null, right, once you reach this here it is null, then you have to just link, you have to create a new node structure like this, assign some value 50, make this null. Your temporary is pointing here, your temp is pointing to the last node. After traversing, you reach this last location where there is null. That name we call it as temp. Just a single command, temps next, this one, point it to new node, game is over. Temps next, point to new node, game is over. This becomes the last element and there is null already. This satisfies the property of linked list, right. So, this is how we add. Again I will repeat how we do the inserting an element at the end in single linked list. We have to traverse the entire list, reach the last node of the list, and the last node's next pointer just point to the new node. Now, let us see how we do the inserting an element at the end in a double linked list. Okay. So, we will try to understand with an example here, then we will go and see the code. So, in a double linked list, I have some elements. Like this. So, we know that our head will be pointing here and there will be two chains, front and back. This will be definitely null because the last node's next pointer will be null and the first node's, that is the head's node's previous will be null, because it does not have any element here and it does not have any element here. Okay. So, let it contain 10, 20, 30, 40. Okay. To be more specific, if you see in terms of number, suppose this address is 200, its address is 100, this is 300 and it is 400. Then this box will contain here 200, this box will contain 100, this will contain 300 and this will contain 200, like this, because this node has to store the previous node's address, that is 200, and here it has to store the next node's address, that is 400. Okay. So, this node will store 100, that is previous node's address, 300, that is next node's address. That way here I will have 300. This is the structure of the double linked list initially. Now, you want to insert an element at the end. So, what you have to do? You have to first create a node structure. I have to create a box like this and assign some value 50, include null. How can I do this? Using the same 4 statements here. If you see, these 4 statements will help me in creating a node structure like this, in reserving some memory with some value 50 and placing the front and back pointers, that is next and previous pointers, to null. Now, what you have to do? Again the question here is insert an element at the end of the list. Here you want to insert an element here in this location. How you do that? How do you insert an element here? You have to traverse the list. You have to traverse the list. You have to keep checking, is it null? No. Is it null? No. Is it null? No. Yes. You reached here. So, this is your temporary now. This is your temporary pointer. We reached at the last node of the list. Now, how many pointers every node is having? 2 pointers, next and previous. So both we have to create and attach. What is the command here? Next nodes, this temporary nodes, next pointer should point to new node. This is new node. What I have to do? This last node, the temporary, this is the temporary node. Temporary nodes, the last element. Okay, temporary nodes, the next pointer. Temporary node is this. Its next pointer should point to new node. New node's previous pointer, this one. New node's previous pointer should point to temp. If I can create these two chains, done. Why? This is already null. No change in the list. Okay, I will repeat the operation what we are trying to do here. Right. See, this is my temporary, this is my temporary. I have reached the end of the list of double linked list. After reaching here, the temps next is this part. It should be pointing to the new node, and the new node's previous, this one, should be pointing to temp. Mutual chain. If you connect that, it is done. We inserted an element at the end of the list, and no other change we need to make. Okay, that's it. This is the logic for inserting an element at the end of the double linked list. See the logic here. What I have to do? The new node's right pointer should point to null. This is null. The left pointer needs to be to the end of the list. Okay, this should point to the end of the list. That is my temporary. Next, update the right pointer of the last node to new node. Update this node's link to this node. That's it. So total 3 operations. This I have to make it null. Anyhow, by default it will be null, but check it once again. Why by default it will be null? If you see the logic here, we are putting null by default. Right. So this I will try to make it null. This is one step. Then you will link the new nodes previous to the temporary node. Temporary is next to the new node. These 3 operations if you do, we can insert an element at the end. Let us see the code snippet and try to understand what we are trying to do here. The important point here is you have to traverse the list. How long should I traverse? Until I reach the last node of the list. How do I identify the last node of the list? This next part will be null for the last node. The next part will be null for the last node. Till that you have to keep traversing. Okay, let us see the code. Try to understand the logic for inserting an element at the end. Right, a good point here is that in the single linked list also, in double linked list also, we are traversing till the end. Okay, because why? We are having only one pointer, that is head. Then what is the advantage of single linked list, double linked list over single linked list? We can come in reverse direction also. Okay, I will, yeah, right. We can come in reverse direction also. There are so many problems. Let me clear it here. I have one question for you. Maybe this is my list. This is my list, and this is again pointing to this direction. Okay, assume there is a linked list like this. I am directly coming to the questions part. Why, where and how we can identify the difference between both the list. There is a list like this. See, it is connected in this way. It has been created in this way. Now the question here is, check whether there exists a cycle in the list or not. Check whether there exists any cycle in the list or not. See, going forward, coming back, there exists a cycle. Okay, this way there are so many applications of single linked list and double linked list. So we are not using single or double here. We are simply using single kind of a thing, but we are also coming back. Right. Okay, so there are so many such applications. The advantage of double linked list is only traversing back. I can come back. How? One, see, in this at the end logic, in here double linked list insertion at the end logic, I am telling traverse the list. How long? Till I reach the last node. After reaching last node, this is your temp, right? This is your temp. Now you can come back. You can come back here by using the previous. You can write temp equal to temp previous. If you write like this, you can come back. You can come back. You can come back. Okay, that way we can come. That's one added advantage over single linked list. Otherwise, both are same. That's why we talked more about drawback of double linked list. There can be some applications where we need to come back also. Okay, you might get the difference of this at maybe once we see the applications of double linked list. If time permits, I will be showing you so many placement level questions on double linked list, which you will get an idea, or else I can refer you one textbook which contains lot of such questions. Okay. No, we cannot use it. To add at the end, I cannot use it the reverse logic. Only thing, I want to print it in reverse direction, I can only go forward direction, I cannot come back, right, in single linked list, but in double linked list I can come back. Operation is costly. See, most of the cases double linked list is has more disadvantages compared to single linked list. That is what if you see this, we already discussed here that double linked list, the only advantage is we can navigate in both directions. Okay, right. So, node in a single link cannot be removed unless we have the pointer to its previous. If you want to delete a node, I should know its previous node. That you can be, no, we need not worry about it because we are always holding previous node, next node. You see these 6 operations actually, implementation of double linked list, those 6 operations you see. Then you may feel some place it is very easy to insert or some place it is very easy to delete. But the drawbacks we are talking, right, it takes more time, inserting and deleting a node takes more time. That is a drawback only, but there can be some cases where we need to come back also. Okay, we need to come back also. In those cases, we need the concept of double linked list. We are just trying to understand how is this implemented. We may not use this directly, we may use some of the concepts from here and use in our single linked list also. Priority, I did not understand priority. Priority in the sense, inserting or deleting, is there any priority for the next or previous node? No. You have to, let us try to see how we are changing the nodes. How are we trying to insert an element at the beginning, insert at the end. Okay. New nodes next equal to head, then heads previous equal to, that can be in any order. It can be in any order. There is no such thing. But there is 1 or 2 cases where we should be very careful. Okay, that is why I request you, let us discuss this completely, then we will see that. We will come to the application part, you will understand it. There are hundreds of problems on single and double linked list. There is no such priority, it depends on the context. Whether you are deleting an element at the end, you have to follow some template. Whether you are inserting an element at any given position, you have to follow some template. Let us see that. So, we were discussing the inserting an element at the end. What is the logic here? I have to traverse the entire list and then insert this element here, right. So, what is the logic here? I am sending the head pointer and the data which I want to insert, let it be 10. Then I am trying to use the same 4 fixed statements to create a node structure like this. Alright, this will insert 10 here, it will put null and its name is new node. Okay. Next, what I have to do here, I am checking if the head is null. It's a blind check, always we have to do. If the head is always null, it means there exists no list at all, and this is the first element you are inserting, then just make this as your head. Your job is done, and make sure these both are null. Make sure that these both are null, because that is the only element in the list, and the last node always should have null and heads previous should have null. That we are trying to verify. Else case, it means list is not empty, there exists some element. In that case, what we have to do? There exists some list like this. So, let me write that new node here. We are inserting an element at the end, right. So, this is my null element, it is linked both ways, this is my head, and here is my new node. This is null, it has 30, assume, right, this is null. So, I will create a temporary pointer temp, I will traverse the entire list, reach here, this is my temp. Once I reach here, temps next means which box? This box should point to new node. it should point to new node. One link is created. Next, new nodes previous, its previous means this box should point to temp, it should point to temp. That's it. These two commands, link is formed. We are adding the element at the end. Okay. So, see here what I am doing, while temp next not equal to null, keep traversing the entire list, keep doing temp equal to temp next, keep doing temp equal to temp next. Once you reach that last node, these two lines of code will bring you to the last node. After that, see, temp next point to new node, new node's previous point to temp. That's it. The link is created. We have included an element at the end. Okay. This is the logic for inserting an element at the end of the double linked list. Any queries till now? Students, any doubts here? Any queries? Please let me know. Okay, right. Let us see the last operation of double linked list in insertion case, that is inserting at any given position. Okay. Before this, let us recall how does it happens in single linked list, then we will come to double linked list. Okay. So, let us take a single linked list and given some position equal to 3. Okay. So, there exists an element like this. This is my null. I am just trying to recall the how do we insert an element in a single linked list at any given position, so that you can easily link it with double linked list. This is my head and we have a pointer like this. It has elements 10, 20, 30 and 40 at position 3. So, this is position 1, position 2, position 3, position 4. It means in between 2 and 3 I want to add a new node. So, what you have to do? You have to create a structure like this, put some value 25, put this null, its name is new node. Now, what you have to do? This is existing structure and this is you have created this new node. After this, what we have to do? We have to traverse the list till where one location before the position. Position 3 is here, traverse till 2, okay, to reach only that point. So, you know the condition, you can write here, take some I equal to 0 and I less than position minus 1, only till that location you traverse. So, let this be your temp, you have reached here by traversing. Now, this is your temp, this is your new node. What you are trying to do? You are trying to link these two, no, you have to link it like this and this has to be linked to this, so that this becomes your third element. Okay. That is why here you see somebody was asking about priority, here there is priority order. Why? I should not break this first. Okay. Do not break this relationship first. Let this be exist like that only. You know, you have new node, right? You have new node. What is temp? I will write numerically here. Temp is pointing to element 20. New node is pointing to element 25. Temp next is pointing to 30. This is the case. So, see the numbers 20, 30. Temp is pointing to 20. Temp next is pointing to 30. Now, this new nodes next, this one should point to which element? 30. No, it should point to 30. Means how should I write the logic? New nodes next should be pointing to 30. 30 means temp next. It should be pointing to temp next. This link you have to create first. Then only you have to cut this. If you cut this first, you lost the control over this node. You don't know what is its address. Okay. That's why first we will try to attach this thing. Let there be two links like this. Let there be two links like this. This is also pointing to 30. This is also pointing to 30. First establish a link between new node and this 30. Then the second step is this temps next should point to new node. That is the procedure we are following to insert an element at any given location in single linked list. Okay. Here there is some priority. First link this one, then break this one. Okay. Let us see the operation, how it happens, how we insert an element at any given position of a double linked list. Again same, what I have to do? You will be given a position, some number will be given to you, some x or some 3, some number will be given to you. What you have to do? You have to traverse till 2, you have to reach till 2, reach there. Let this be your temporary node. let this be your temporary node. Now you have got the new node here. See, you have you know how to create this new node structure, put some value 15 and make this both null. That also you have done, and its name is new node. Now be very careful here. See what operations we are doing. That's why I said no, don't break these two first. Don't break these two links first. First thing, new nodes next. This is my temp. So write numerical like this. Temp is pointing to element 15. Let this be 25. Temp's next is pointing to 7. Now this data contains some element 25. Now where I should point first? New nodes next should point to 7. It means new nodes next should point to temp's next. Why? Because temp's next is this. It should point to temp's next. With this, what we do? With this, we are trying to create a link. Okay, this link is created because of that. Then next step, notice next step, this new nodes previous, you are linking it to temp. New nodes previous, you are linking it to temp. So this way we at least got control over both the nodes, this node and this node. Then temp's next should be new node, and temp next previous should be this element. Okay, I will make it much simpler. See, you are having temporary node T, which is at location 15. Let this be T1, let this be T2. So T1 is at 15, T2 is at 7. Okay, you are having a new node N that is at 25. Right, you are having a new node N which is at 25. That element is 25. First, what you have to do is N's next should point to T2. This chain will be created. N's next should point to T2. Or let us take N1. N1's next should point to T2. This link we have to create. Okay, created. Next, N1's previous, this one should point to T1. It should point to T1, this node. So with these two statements, here it is my T1, this is my N1. With these two statements, this chain is created and this chain is created. Over. Next, what I have to do? This T1's next, which is pointing to T2, should change and point to N1. So T1's next should point to N1. T1's next should point to N1. Next, T2's previous, this one, T2's previous, which was earlier pointing to T1, T2's previous should point to new one, N1. It also should point to new one. So these are the 4 statements. Here there is some priority order if you see. Why I cannot simply break these two? See, don't simply write T1's next is equal to new node. If you do that, you break this chain. You don't know its address. Okay, you don't know T2's address. That's why using new node's next point it to T2, new node's previous point it to T1. So you established a connection between T1 and T2. You came in between. Then you break these two existing ones and map it. How T1's next should point to N1 and T2's previous should point to N1. Okay, so this is the logic. That's why it is little complex to understand how linked list operations are performed. That way it gives more scope for the interviewers to ask you so many questions in writing the logic for implementing double linked list or single linked list operations. They will ask you to type complete code. Okay, just tell what is the logic, how you are doing it. That logic they are asking. Those 4 statements we just saw, those they are asking. Okay, so this is the logic of inserting at any given position. I will repeat what we are trying to do. You are traversing and reaching to temporary pointer. Temporary is next, you are making a T2 and the new node is N1. Then new nodes next should point to T2, new nodes previous should point to T1. T1's next should point to new node, and T2's previous should also point to new node. That way we can you are sending 2 directions first, then you are taking 2 arrows. That way we are trying to create a connection and insert an element at the given location. Okay, let us see the code snippet. Let's try to understand the code for implementing double linked list insertion at any given position. Okay, so obviously head and data and also position. Why I need position? Where you want to insert. I am creating a temporary pointer which is pointing to head. These four violet colored statement are default statements. They are used to create a node with some element here 10 and with null like this, and its name is new node. Now, if the head is null, again this is a default check always. If there is no element in the list, this should be our head, and that should be the only element in the list. So this you can avoid if there exist some elements in the list. Now next what I have to do, if there are some elements, what we have to do? We have to traverse the list. How do I traverse it? You see, using for loop. For I is 1, I less than position minus 1. I less than position minus 1. Why minus 1? I should reach one element, right? Whatever is the position, if this is 1, 2, 3, if the position is given as 3, I have to traverse till 2. 1 before that I have to stop. For that we are taking a position. What I am doing here? Temp equal to temp next. Keep traversing until you reach the positions but one node. Positions but one node till you reach, you keep traversing it. Okay, over. Next what I have to do? New nodes, that four commands like this. This is T1, this is T2, and this is your N1. Okay, right. What I have to do? New nodes previous, point it to temp, that is T1. You form this link. Then new nodes next, point to temp next. New nodes next, point to temp next. But this is this link. Then now both away directions are over. Now think about out degree, in degree direction you see. So temp next, that is temp next means this one T2. Its previous means this box should point to N1. It should point to N1, that is new node. Next temp next. Okay, this one, this is temporary. Its next is this. It should point to new node. So with these four statements, after traversing using these two lines, with these four statements, we are able to establish the connection between inserting an element at any given position in double linked list. Okay, so what we are trying to do here, if we summarize, we are just trying to link this next and previous pointers to this new node in a sequence such that we don't lose the control. Okay, so this is about double linked list insertion operations. I hope it is clear how we are inserting an element at the beginning, at the end, and at any given location. So next we will study about inserting, deleting elements at the beginning, end, and at some given position of double linked list.